Thank you, Bridget. As Bridget mentioned, I'm Martez Reed. This talk is going to be on intelligent pipelines, which is intelligent deployment pipelines, which is a perfect segue from John's talk. A little bit about myself. I am a principal field solutions developer at Puppet. Really what that means is I work on the education enablement team. I help with training both externally as well as internally at Puppet. Roughly 10 years of IT experience, and my focus probably the last 7 or 8 years or so has been on automation. So a couple of ways to find me: LinkedIn, Twitter, GitHub. Do a bunch of different things that are hopefully very interesting to other people, and there's a bunch of different ways to find me. So let's kind of dive right into it. Let's start with kind of preferencing what CI/CD is. It's one of the common words that people hear. Oftentimes people don't really know what the full intricacies of it are, but for a very high-level overview, typically the CI part is the continuous integration, which deals with the automated testing as well as potentially automated builds of code. Continuous delivery and continuous deployment, this is one of the things that sort of I tripped over when I first started getting into the whole CI/CD thing, like what's the difference between CD of delivery as well as deployment? For me, kind of the simple way to think of it was that delivery was basically making sure that the package was ready to actually ship, or in this case, whether it's code or whatever, to be able to ship to production, and there's actually a manual gate before it gets to production, as opposed to deployment, which is that essentially the code is going automatically through to your production environment. So now that we've gone over that, so this is a common diagram of a CI/CD pipeline that you'll often see. And for me, one of the big things is, kind of the reason for this talk is that we often see this, and there's a box dedicated to deploy to production, and right before deploy to production, there's some application acceptance test. But for me, I kind of want to focus on the area here that there actually rarely ever is a box for that I see is, how do I make that decision to deploy to production? I think for most people, it's oftentimes a gut feeling of, yeah, now it's about the right time. The application's been tested, everything is good to go. And then for some people, it's just random guess on what to do. And so for me, kind of to highlight that was, I think for most people, deploying into production is really just a black box in terms of at least our mental model as it relates to, if we're not deploying to production, let's say multiple times a day, there's a situation where we start to lose context of what is or isn't in production. This kind of alludes to John's talk of the reference of, there's oftentimes so much infrastructure as well as different dependencies within a production environment that it's very difficult for any one person to keep track of every particular nuance of the environment. So I'd like to think that essentially we're, for the most part, deploying into a black box. The thing I would liken this to is the Frogger scenario, for those that have played the Frogger game. Imagine playing Frogger, but having blinders on to where you can't really see to the left and can't see to the right. You know a truck is coming, but you just can't see the truck. So you kind of jump out there and you get hit by a truck, or maybe sometimes you're lucky and you don't get hit by a truck. It's really just kind of a crapshoot. So that's what kind of this black box scenario is for most. And so how do we take those blinders down? For me, it's starting to look at, kind of as John mentioned, things like telemetry within our environments. What is the current state of the environment? We've got some things that are already in the IT ecosystem that help with some of these things. And so things like Jira for ticketing, actually interrogating potentially AWS for some information. Things like Splunk, your data log, to get information about what the environment is that we're actually deploying into that maybe we haven't actually deployed into in maybe a month or so, or maybe even longer. So an example with AWS might be, is a certain availability zone in AWS actually up? I mean, it might be a scenario where there may be either nothing in there currently, or maybe there's something there and maybe it's not actually degraded or not actually being utilized because maybe it's a redundancy component. So before we actually deploy to production, maybe we can check that to actually validate that it is actually up and running. In addition to that, I mean, there's a lot of different things that we can validate within the environment in terms of AWS, things like the EC2 status, S3, IAM, which may be, especially with like IAM or KMS, things that may not be used on a daily basis for some environments, to where I go to push to production, and now there's an issue with the actual deployment because one of the services is unavailable. And so it's not an outage, but it does take up time and also cause churn in terms of what actually needs to be done. And oftentimes, as I've realized, some of the errors with the tools that we use may not throw this specific correlation that says, hey, there's an issue with KMS, or KMS is in a degraded state. Typically, we'll get the actual symptom of, hey, I'm trying to deploy an EC2 instance, but I can't actually encrypt the volume. And the actual root cause of that may be an issue with KMS. So starting to look at things to help us collapse that time of troubleshooting, as well as to help us gain better context when we're trying to troubleshoot. In addition to that, this is an issue I've ran into multiple times when deploying is, in larger organizations, there are multiple teams that manage different aspects. In this case, let's say an AWS environment. And when trying to deploy a certain application or an EC2 instance or whatever it may be, it's dependent upon another team's security group being available within the environment. And so I go to actually push the code, and there's a failure because the security group isn't there within the environment. While it's not a major issue or an outage, it does require time for me to actually walk through that process to address the issue. So things like the required security groups, required KMS keys. So oftentimes these issues are more things that we see from the symptom side of, I try to run an operation and the operation fails, and most applications I've seen don't throw very good errors to really get you right to the root cause, or maybe somebody's written an article or a blog post that maybe gets you there, but that's still a couple of hours as part of that process to try and remediate whatever the issue is. For me, this is a really big one, because this steps out of the purely technical and starts to step into the interdependencies of different teams. So in this case, maybe there's a network team that manages, let's say, an AWS VPC configuration, VPNs, firewalls, things like that, and potentially looking at a source of truth like Jira. Hopefully, if it's being updated and maintained properly in terms of ticketing, then we can start to leverage that information about the environment to potentially help us to make a better decision in terms of when we make a deployment to production, to be able to identify maybe there was maintenance last night that the network team did on maybe some critical firewalls. For me, I think that would be really helpful to be able to have that information when I make a decision to deploy to production, because maybe that's the issue. Maybe the network team upgraded a Palo Alto network firewall within AWS to a newer version, and now I'm experiencing issues in my production deployment, but now I don't have that direct correlation to understand that, hey, they updated something on the Palo Alto firewall, maybe there's a bug there, maybe there's an issue there that's causing an issue with traffic coming into my application, but without actually knowing that the network team made that firewall change, I may not have the proper context to actually properly troubleshoot that. And so I spend maybe hours, maybe days, maybe weeks, maybe months, potentially trying to track down the issue of what happened. And so things like that of ongoing maintenance checks, of identifying other teams that are doing maintenance within the environment to understand that correlation possibly between when I last pushed to production to when I now push to production, to understand the potential ramifications of what my push is going to have to deal with in the environment. In addition to that, I mean, being able to look at our telemetry to be able to ingest additional data around, is it maybe there's something going on right now where maybe customers are flocking to the website more for, let's say, maybe a potential offer or a deal, or maybe it's just one of those occurrences like everybody wants to buy something from our website now. Is maybe this the right time to push to production while we've got maybe 2x or 3x the number of customers that we would normally have? So in addition to that, we can also start to look at potential other dependencies within our environment in terms of what their performance is, to identify scenarios where, kind of as John mentioned, maybe a console agent is causing issues in the environment for these particular applications. It's not something that's very specific to my application, but it is going to affect the application of maybe there's additional database load of in the environment. And maybe it's a scenario where my application, I've made a new feature change to where it now puts additional load on an already taxed database. And so now I'm chasing my tail because there are performance issues, and I'm trying to figure out why there are performance issues. Oh, most people are going to say, well, you just pushed new code to the production environment, so it must be the application code that you pushed. But maybe it was a combination of an existing issue as well as the code change. And then another thing is looking at our logging and information, starting to actually make real use of that for additional information and additional insights. So starting to look at comparing potentially what we've got in our existing pre-production environment to our production environment to get insights from there. And also starting to identify potential transient errors that aren't really being tracked but are actually creating issues. So for me, this is great information and great insight to help remove that black box of what production is and start to make it a clearer picture. And so for me, it's also starting to potentially look at the diff between what our lower level or let's say pre-prod environment looks like from our production environment to get real insights that we can leverage to make actual decisions around how we deploy to production. And so kind of on the logging example, one of the things is oftentimes I've been in environments where there's a bunch of errors and if you're a more junior person or somebody new to the team, you might go and say, well, hey, there's all these errors in the logs. And the other person says, well, yeah, that's fine. That's how it always is. That's usually how most environments are, is especially with Java. I've looked through Java stack traces and it's isn't somebody going to fix this? Oh, no, that's perfectly fine. That's how the application is supposed to work. And so when we deal in these real life scenarios, how do we address that issue of I can't go fix every single error, but all I'm going to get is noise. So how do we start to actually make use of that of, let's say before I push to production, I've got a pre-prod environment that mimics the production environment, and all I'm really doing is I want to identify the difference between the two. I'm expecting error 101 and error 609, but if I see error 933 in the pre-production environment, and I do a diff between that and the production environment, I can start to see, hey, there's an actual issue as opposed to the noise as usual that we see in most environments. And the other thing for me is also as we start to step more and more towards sort of everything being codified, we get into scenarios where we can start to do this of, let me take my CloudFormation or my Terraform and actually do a diff between the two to start to see if there are issues that are going to potentially present themselves because of differences between the last time I pushed to production and the next time I push to production to identify, get a good sense of what's actually changed within the environment. And so this is really, for me, critical in scenarios where there are multiple teams working on multiple components within the Terraform code to be able to leverage, okay, the network team owns the networking piece. They've done it all in Terraform. The security team owns the security piece. They've done it all in Terraform. Can I potentially do a diff between the code that they manage and the code that I manage from the last time I pushed to production and the next time I push to production to be able to see, at least see, what has changed within the two environments between the time of the last push and the next push. The kind of extending upon that model is starting to look at essentially everything being as code to start to store artifacts of essentially the whole map of what production looks like at the time I deploy to production and be able to compare it to the next time I push to production. So the code, let's say there's a Golang app, it's already being codified. It's stored in GitHub or GitLab or whatever it might be. I've got that. I can do diffs on that to see all of the code changes from the last version push to production to the new version push to production. If you're using configuration management, you can also store that. The Terraform, the Packer that maybe the application is running on for the AMI or the template or whatever it might be. And I could potentially store that in like a CMDB, like a ServiceNow, and be able to version that as version 1.1 of my application when it was pushed to production. This was the state of all of the components that go into building out the infrastructure. and then be able to do a diff quickly between the two if the need arises to say what changed between now and then, to be able to say, hey, maybe it's a console config or something like that, to be able to identify issues that like that we can actually be able to track down very quickly because we're actually being able to look at data and metadata about the environment. So along the lines with data, there's a session going to be on this, but chaos engineering. So the thought with chaos engineering is more thoughtful than this, but for the layman for me is break stuff and see what the impact is. So this is the actual more technical description of what chaos engineering is. Essentially, you're running experiments to see what the state is of the environment. And so for me, this goes along the lines of getting additional data into the environment to be able to make rational decisions and thoughtful decisions about what we want to do in terms of deployments. So kind of walking through the example, this is a scenario where there's an AWS load balancer and there's 2 EC2 instances. Traffic's going to the first AWS EC2 instance, and life is good. But there's an outage for some reason. Somebody killed off the instance, it broke, whatever it might be. And so now, for most that have worked with load balancers and AWS, what's the thought of what's going to happen? The thought is, it's going to fail, traffic's going to fail over to the other EC2 instance. But what happens in a scenario where it doesn't actually fail over for various reasons? Whether it's an invalid health check, manual fixed health check, somebody actually did something maybe they shouldn't have done and went into production and made a change manually on the console, and now you push some new Terraform and it breaks that health check, so now you've got bad health checks. But when you push the code, you didn't realize that there was a bad health check because everything was going to the healthy EC2 instance, or even just the failover time. So the goal of this is to start to ingest additional data in terms of, especially in like a pre-production environment, about what the potential impact is going to be when you push to production. In addition to that, start to look at issues with the EC2 instance. So there are a number of things that can impact what's going to happen in terms of the availability. And so the goal is to start to identify some of those things before we push to production. And this is a number of tool examples related to chaos engineering. One is Netflix's Simming Army, Chaos Toolkit, which is an open source tool, as well as Gremlin, which I think they're actually going to be doing a session later today. But the goal is to be able to break stuff, to try and figure out where the issues are within the environment, to be able to ingest that data. And so kind of along those lines, there's a lot of data, a lot of telemetry, a lot of information being ingested and we're being bombarded with. For me, kind of the goal is to start to think less about the mental model of information that I can keep in my head as it relates to what does the environment look like, and start to really lean towards and take advantage of some of the tools and platforms that we are now starting to see actually really become more prevalent, such as machine learning. I did reference machine learning. I will not mention blockchain or some of the other buzzwords. I did actually think this was relevant. But essentially, the thought around machine learning is to have the machine start to do some of the work for you. And especially when we start talking about taking these vast amounts of data in, how can we actually make actual sense of this data? So real simply, 2 standard types of machine learning, supervised and unsupervised. Supervised basically being you giving the machine learning the answers beforehand. Unsupervised being it kind of figures out that data. I'm sure there's more people that are well-versed on machine learning that can provide better explanation of that, but that's, as a non-machine learning person, that's how I grasp it. So kind of as I've talked through this, how do we take all of these different data points and start to ingest them to actually form insights to help me actually make an informed decision when I push to production, as opposed to, yeah, just push the button, it's good, there's no issue, and then everything breaks. And so for me, one of the things around starting to be able to leverage those insights is ingesting all of that data from our continuous integration process, as well as our continuous delivery process, and even production, and sort of feeding that into a central point to where we can start to, as human beings, start to look at this information in a more sensible manner and have that be our decision as it relates to when do and don't I push to production, and actually be able to have essentially almost like a dashboard that says, this is what things look like. Yes, it's probably a good time to push to production. No, it's not a good time to push to production. And over time, that'll start to be refined and start to be able to potentially used as input into potentially automated machine learning around making a decision to where it's not a human gate anymore. Then we can start to leverage a scenario where it's the machine making the decision based upon the decisions that the humans have made prior to. And maybe it's not even a fully automated manner. Maybe it's certain scenarios where I've provided guardrails around quote unquote the machine to make a decision. Maybe if it's make sure there are no open issues in Jira that are critical for networking or security, or maybe make sure there are no metrics that are above this certain threshold. And then if it meets that certain criteria, then maybe it's time to make the decision of, yes, make the push to production. And so this isn't an all or nothing scenario where like, hey, let's just turn it over to the machines and let's just have them sort of figure out when and when not to push to production. There are guardrails and things that we can do to put in place to provide safety, but also take advantage of the machine being able to ingest data about the environment at a much faster rate than we're able to. And so when we start to think in this sort of methodology where I'm ingesting data, not for me to look at it, but I'm ingesting the data for the machine to process it and for me to be able to actually gain the insight from the information that the machine is processing, then it's a scenario where I don't mind turning on extra telemetry or extra logging because I'm not actually ever going to be looking at it myself, only if there's an issue when I'm allowing the machines to actually start to process that and actually take advantage of the advances in technology outside of just going full-blown, we're going to do everything's going to be AI, and the machines are going to think for us. I think that'll come at some point, but I don't think that's where we're going to be at for the next probably 20 to 30 years. So while we're in this place of where machines don't do everything for us, I think it should really behoove us to take advantage of the insights that we have available to us. I'd like to thank you for your time. I am Martez Reed. Hopefully this talk was helpful.